Lesson 3, dividing radicals. Okay, so up until now, what we've done is we've talked about what radicals are, how they convert from entire to mixed radicals or mixed to entire, and we've also talked about adding radicals. So that was really like combining like terms, is what that was all about. And then we did multiplying radicals, which was pretty straightforward. Dividing radicals going to be similar to multiplying, but obviously we're just dividing now. Prerequisites: we're going to need to be able to simplify fractions and multiply radicals. So kind of what we've talked about already with multiplying monomials and binomials. So what I mean by that is this, right? So this is a monomial, there's one. This is a binomial, there's two terms there, right? So being able to multiply stuff like that, right? So that was that distributive property we talked about in the last lesson. Okay, so number one here says simplify 36 or square root 36 over square root 4 and 36 over 4 all square rooted and square root 9. What I mean by that, just put those all in your calculator for a second and see, do you get the same answer? Do you get 3 for an answer? You should. They're actually all the same, right? So going square root of 36 over square root of 4 is equal to 9. So we can write, what the idea here is though, is you can write something like this where it's square root over 4. You could put that all under the square root and it means the same thing. And we just kind of got the same thing for number 2. So using the above as a guide, make a prediction about the expression, this and this. Well, I'm probably just going to give it away here. Here is what we have. It's the division property. And just like what we kind of said up top, square root of something over top, and then square root of something on the bottom, that's equal to the square root of both those things inside. Notice though that this says A needs to be greater than or equal to 0 and B needs to be greater than or equal to 0. That comes again because from this you can't have the square root of a negative on the top or the bottom. You just can't have it. It won't be a real number. So first off though, division property. That's what we need to know first. So looking at some examples here, it says determine an equivalent form for each expression without using a calculator. So really all we have going on here is that you're able to divide the numbers. So imagine there's like a 1 on the bottom here, right? Just kind of you can't really see it though. You can divide the numbers and you can divide the radicals, and that's it. So really, when I was going to simplify this, this would just be, well, 3 divided by the 1 that's on the bottom, just doesn't do anything, right? It's still a 3. And then 30 divided by 5, just square root 6. And that's it. That's all that's to it. So this one isn't too bad, right? Square root 24 over square root 3, well, that's just square root 8. 24 divided by 3. All right, now we're getting into our fractions, though. Hopefully you guys are all good with your fractions. So I know this is kind of a struggle point for a lot of students. So all you got to do, the numbers first and then do these ones second and then kind of combine them. So if we were going to simplify 6 over 4, I'd say, okay, well, what goes into 6 and into 4? Well, 2 does. So 6 divided by 2, that's 3. 4 divided by 2 is 2. So 6 over 4 simplifies to 3 over 2. What goes into 40 and into 45? Well, 5. So this will just simplify to the square root of 8 over 9. Just while we're at this point, I just want to make sure that you guys understand how this kind of thing works too. You could also write this like 3 times root 8 over 2 times root 9. They're the same thing. Sometimes students get confused about that. They think these are like saying different things, but they're not. So both of those are equivalent. Okay, looking at this one, this is just, oh, I didn't do them in order. 15 divided by 3 is 5, so root 5. This is going to be root 18. But I should probably simplify that. I should rewrite this as 9 times 2, and then take the 9 out as a 3, so this would be 3 root 2. And then this one, I can't really do anything more with the numbers. 9 over 2 doesn't really simplify anymore, but 24 and 18 does. 6 goes into both of those. So I'm going to rewrite this as 9 over 2 still. But 24 divided by 6 was root 4. 18 divided by 6 was root 3. This also could have been written as 9 over 2 times 4, or root 4 over 3. Same thing. Okay, now a new concept, rationalizing the denominator. What this means is we want to write the denominator, so number on the bottom, as a rational number instead of an irrational number. So first off, like, do you remember what a rational or irrational number means? Well, if you think about the most popular, the most famous rational or irrational number, pi, and I push enter, you can see it goes 3.14159, but maybe you've heard this before. These numbers keep on going on forever. We call that irrational. It's not like it doesn't just end. It doesn't just give us a number. So yeah, that's considered irrational. So we don't want an irrational number like pi in the denominator. So another example of an irrational number, square root of 2. Same thing. These numbers would continue on forever. It's an irrational number. So that's what we mean by rationalize the denominator, is don't leave any of these numbers with an infinite amount of digits behind it hanging around in the bottom of the fraction. Okay, so that's what we mean. Okay, so I'm going to show you how to rationalize now. So here's some examples. The first thing we want to do though is, if you can simplify it first, you want to simplify it. So I'm going to look at a here. I can't really simplify that anymore, right? I can't turn this into a mixed fraction, or sorry, a mixed radical. So we just need to kind of start to rationalize it. So the way you're going to rationalize it is we are going to multiply this thing by something. And what we're going to multiply it by is the square root of whatever's in the bottom. So we're going to multiply it by the bottom by the square root of 7, but we also need to multiply the top by the square root of 7. And the reason why we're going to do this now is, if you kind of look at what's going to happen, we're going to have the top is going to be multiplied by the top, the bottom is going to be multiplied by the bottom. It's the most interesting part is what's happening to the bottom. So if we do this, we've got root 7 times root 7. Well, the two square roots cancel, and we end up with just 7 on the bottom now. And on the top, now we have 7 times root 7. We're not quite done, because now we have 7 over 7. We can cancel those. So this is the same as just root 7, or square root 7. Now, how did I get away with multiplying by this, square root 7 over square root 7? You might say, like, well, I can't just multiply by something. That's going to change it, right? But if you look closely at what I multiplied by, I only multiplied by 1. Square root of 7 over the square root of 7, something divided by itself is always just 1. So we didn't really change anything. All we did was, it was like a little math trick that we do. You're going to do quite a lot is like in future courses, is multiplying by 1, but we're just like making up that 1 a little different. Okay, so let's look at B. Well, we need to multiply by square root of 5 on the top and the bottom. So square root of 5, square root of 5. On the bottom, we've got square root of 5 times square root of 5. That's just 5. On the top, we've got 5 times the square root of 5. 5 cancels with 5, and our answer is just the square root of 5. Now for C, we could do two things. You could right off the bat, if you wanted to. It's not gonna. It's kind of up to you. We could just multiply by square root of 50, and square root of 50 on the top, and then we've got 5 times square root of 50 over 50, and then you could simplify this 5 and this 50. So this would, we just have to divide 50 by 5. So this is the square root of 50 over 10. But we also need to write this 50 as a mixed radical. So this is going to be square root of 25 times 2 over 10. And then that's going to be 5 times root 2 over 10. And then that's going to be just root 2 over 2. So you can do it that way. But I'm just going to show you, it might be a little bit easier to, well, I'll show you in the next one. So it might be a little bit easier to do it this way instead. Give your number 18 on the bottom. Let's simplify that first. So let's rewrite this as 3 over the square root of 9 times 2. So then that is equal to 3 over 3 times root 2. 3's cancel. What I have now is just 1 over root 2. Now I need to rationalize it from this point. So we're going to multiply the bottom and the top by the square root of 2. So that turns into the square root of 2 over 2. So I guess what I'm saying is that you can turn this into a mixed radical or like simplify as much as possible first, or you could do it at the end. You'll end up with the same answer. So I would personally change it first. So for number 3, it says, what examples of multiplying do we have that resulted in rationals? So numbers that just end, right? So something like 4 would be a rational number. Or like 2.1, where it just ended. That would be a rational number. So if we had something like this, let's say, and remember multiplying binomials. So let's say in a situation where you multiply it by 2 root 5 and then minus 3 root 2, something like that. Well, we did an example of one like this before. Let's kind of see where it goes. So let's multiply this thing. So we've got, remember our FOIL, it's going to be that one times that times that one times that, and that one times that. So let's do the first one there. So root 2 times, or 2 times root 5 times 2 times root 5. So that would be 4 times, well, root 5 times root 5, that's just 5. So just 4 times 5 is our first one. Okay, next one. We've got 2 times, so this one times that one. That's going to be negative, right? Because it's positive and a negative. So negative 6 root 10. All right, now this one and this one is going to be positive 6 root 10. And now the last one is going to be 3 times 3 is 9, and it's a negative, right? Negative 9. And then root 2 times root 2, that's just 2. You'll put those in brackets too so we don't mess up our orders. Okay, so now you can see this is a special case where this and this are exactly the same, but one's a negative. They cancel, they equal 0, right? So that and that is just gone. And what we end up with here is just 20 minus 18. So we end up with 2, which is a rational number. That's kind of what we were getting at there. And what this is called, this idea here of having a positive and a negative of like the exact same binomial, but just positive and negative, those are called conjugate pairs, or it's called like a conjugate. So yeah, conjugates. And the reason why we do that is because it makes things simpler, and we're going to show why we're going to do that here in a minute. So word to remember, word of the day, conjugates, or conjugate pairs. And maybe while we're here though too, write down this. So middle terms cancel. So when you're dealing with a conjugate pair, all we had to do to figure out what the answers were here, these middle ones were irrelevant, right? They didn't come into play at all. So all we had to do was go this one, the first one, times itself, and then the second one times the second one. And those were our answers. That's all. We didn't have to do 4 things. We only had to do 2 things because 2 of them ended up giving us numbers that canceled in the end anyway. Okay, so let's put this to practice here. Okay, so rationalize the denominator of each of the following. So we don't want square roots in the bottom. So what I'm going to do is I'm going to multiply this by something on the top and bottom. What that something is going to be is going to look really similar to this, but the sign's going to be different. So instead of root 5 minus root 7, it's going to be root 5 plus root 7. And I can't just go around like multiplying by that. I have to multiply the top by that too, because that's just equal to 1. I haven't changed anything, right? This whole thing I have in green here is just, that's 1. Okay, so if I do that, so let's write what we have left here. I'm just going to leave the top as 3 times square root of 5 plus square root of 7 for now. The bottom, remember I said since the middles are going to cancel anyway, when you multiply by the conjugate, all we got to do is multiply that one by that one and that one by that one. And then you're done because the middles were going to cancel. So if we do that, we get root 5 times root 5. Well, that's just 5. Root 7 times, or negative root 7 times root 7. Well, that's going to be just negative 7. So now let's rewrite the top here. We've got distributive property. It's going to be 3 times that and 3 times that. So we've got 3 times root 5 and then plus 3 times root 7 all over negative 2. And that's it. That's now rationalized. All right, moving on. Let's do, I'll do them in order this time. B. Okay, so let's multiply the bottom and the top. It's got to be by the same thing. It's going to be root 5. Now, not plus, it's going to be minus. It's got to be the opposite sign. So minus root 3, root 5 minus root 3. Okay, so our top, I can do this right now in one step. So it's going to be 4 times root 5, 4 times negative root 3. So our top is going to be 4 root 5 minus 4 root 3 all over. Now it's just going to be that one times that one and that one times that one. So that's just going to be 5 minus, because positive root 3 times negative root 3 is going to be negative. So it's negative 3. So write one more time. 4 root 5 minus 4 root 3 over 2. And that's our answer. Okay, so I'd like you guys to go ahead now and when I tell you, you're going to pause it. You're going to finish these ones, and then I'm just going to pop the answer up at you. So I'm not going to go through them each individually, but the answer will just be kind of there for you. So go ahead and pause the video now. Okay, so there's your answers. Hopefully that went okay. I might go through this last one though, F, just to make sure that you're okay on that one. So what I did, you can see everything's looking kind of similar to the other ones. And then I multiplied, the top and the bottom. And this is what I got for the top. I had 6 up here. And then the last one, when I went this times that, I got 6 for that, right? Because that's really just 3 times 2, which is 6. So now I've got 6 minus 6. So those just ended up canceling or equaling 0. And then what I did is I had, this is like 1 times square root 18 minus 3 times square root 18. I combined those like terms to be negative 2 square root 18. Then what I did, you could have canceled, or you could have simplified this 2 and 4 at this point too if you wanted to. But what I did instead was I split this 18 up into 9 times 2. I took out a 3 out of this. So then that 3 I took out times the 2 that was already there became 6. And then I simplified that. Negative 6 over negative 4 became 3 over 2 times the root 2 that's now there. Okay, so hopefully that made sense. What I'd like you guys to do for homework is that homework assignment that you'll see on that workspace as well. So that's going to be it for that lesson.